Okay guys, welcome to year-end review number 2. This time it's going to be a little bit of a longer review because I'm going to cover 2 units in it. So in class we did a unit called quadratic functions, and then we backed that up with another unit called quadratic equations. So I'm going to cover it all in this one review. By far, this is our most important unit that we do in 20-2. It is what most of the algebra in 30-2 is based off of. So it's a really important unit that we make sure we have a solid foundation in. So what do all quadratic equations look like? What do all the graphs look like? So all quadratic equations, they must have an x squared. Now they may have other terms as well. So they may have like an x squared and an x term. They may have a constant term on there, but as long as they have an x squared, then all of the graphs will look the same. So the most basic graph, so y equals x squared, if you put that into your calculator, it looks like a smile. So it looks like a U shape. It goes through 0, 0, 1, 1, and negative 1, 1. And we take that basic U shape, and depending on what number, we put around that x squared, we can make that smile turn upside down or make a smile into a frown. We can move that around. We can do whatever we want with it. So we did a whole lot with these U-shaped graphs. The U-shaped graphs are the ones that predominantly happen in nature. Pretty much everything is modeled on a quadratic curve, simply because of the concept of gravity and friction. When you bring gravity and friction into any type of scenario, the graphs that result from that scenario always end up looking like a quadratic. Okay, so let me just go back here and make sure I did everything on that slide. Yeah, I did. Okay, so the first thing we did with quadratics is we used our calculators to find values on that curve. So there was a whole bunch of words I hit with you with this unit. So we had the vertex, we had the maximum and minimum value, we had the axis of symmetry, that's also sometimes called the line of symmetry. We had x-intercepts, y-intercepts, domain, and range. So let's just go through and use our calculator, hopefully remind you the buttons that you have to push. So we've got y equals negative 3x squared plus 2x plus 5. So I'm going to go calculator. So we're going to go to y equals. We're going to clear out anything that's there. So we've got negative 3x squared plus 2x plus 5. Now, the very first time that you graph, if you're not sure what your window settings are, the very first time that you use your calculator to graph in a long time, hit zoom and hit 6, and it will automatically set your window settings nice to a nice like 10 by 10 grid. Now, the thing with the calculator, and we talked about this a lot in class, is the calculator can only find what it can see. So if it can't see, like let's say the vertex, or if it can't see an x-intercept, it won't be able to find it for you. So you will have to muck sometimes with window settings so that the calculator can find what you need it to. So I'm just going to have this over here. So when you're asked to sketch a graph in this unit, you don't really have to plot any points. It's just a matter of just physically sketching out what you see, making it fairly approximate, and then going from there. So pretty much everything that we use in this unit is under our trace menu. So the way we get to trace is by going second calc. So second calc is this menu right here. So number 1, so value, that one was used specifically to find a y-intercept. Number 2, 0, that one was used to find x-intercepts. 3 and 4 we used to find the vertex. And then we didn't use 5, 6, or 7 really too much in this unit. So when we talk about the vertex is either the top of the hill or the bottom of the valley. It's either the highest point or the lowest point on the quadratic. So we can clearly see on this quadratic that our vertex right here, the vertex, is right here at this point. It's at the highest peak, okay? So our vertex is going to be a maximum. So the way we find the coordinates of the vertex is we're going to pick number 4. Now you're going to be immediately prompted with the word left bound. So what you have to do here is you have to enter an x value that's on the left side of that vertex. So any x coordinate over here that's on the left side, I'm going to go negative 3, and I'm going to hit enter. Notice my arrow or my line is to the left of the vertex, which is exactly what I want. Now, it doesn't matter how far left you go as long as you're on the left-hand side. For the right bound, again, I'm going to enter an x value that's on the right side of my vertex. So I'm going to pick 5. And again, notice as soon as I hit enter, I now have an arrow on the right side of my vertex. So again, it doesn't matter how far right you are as long as you are to the right. Now, you cannot plug in numbers bigger than -10 or +10, simply because the graph only goes to -10 and +10. So again, remember the calculator can only find what it can see, so you have to put stuff on there. Now, the next feature of the calculator, we've talked about this one before, most stupidest feature ever. It actually wants you to type in what you think the answer is, but as soon as you hit enter, it will just tell you the answer. So we're just going to hit enter to get past guess, and we get out our answer. So we're going to round that to 0.3 and then 5.3. So when we write the answer for vertex, we always write it as a coordinate point. So it's 0.3, comma 5.3. Okay? So that's this point right here. So 0.3, 5.3. So for max and min, we say that it has a maximum of 5.3. It's always the y value. Okay, so this is the maxing out point of my graph. Line of symmetry. So the line of symmetry is the line that divides the graph exactly in half. Now we'll always go through the vertex. So we always write the answer as x equals, and then we write 0.3. Now, it's a line. It's not a point. It's not a dot. So because it's a vertical line, we have to have the x equals there. So to find the x-intercepts, now we can clearly see on our graph that we have 2 x-intercepts. We have one here, and we have one here. So we're going to have to do this process twice. Okay, it can't find both of them in one step. You have to go through it twice. So the button that we push for x-intercepts, so second trace, the button that we push is number 2 for 0. So we're going to hit number 2. Now again, you're going to be prompted with a left bound, right bound. So if I'm looking for this one right here, a number on the left side, let's say would be -3. Now a number on the right is trickier because for the number on the right, you can only pick a number that's kind of right in this area right in here. So I'm going to pick 1. Now you're welcome to pick like 0.5 or -0.2. You can more than welcome to put decimals in. But again, notice my x-intercept right here is between my 2 arrows. So if I hit enter, it will tell me my x-intercept's at -1. So now my x-intercept is here at -1. Now I just have to do the other one. So again, to find this one, this will be a number on the left side. This will be a number on the right side. So for my left, I don't have very much choices. I'm only going to have to be able to pick like 1 or 0.5 or something like that. So second trace, pick number 2 for 0. Okay, so I'm going to go with 1 for the left, and I'll go with 3 for the right. So again, notice my x-intercept is right between those 2 arrowheads. Hit enter to get past guess, and I get 1.6 repeating. Okay. Y-intercept. So you have a couple of options for y-intercept. Option number 1, again, use the same menu, second trace. This time we pick number 1 for value, and we're just going to enter in 0 because y-intercepts occur when x is 0. So right there, my y-intercept is at 5. The other thing you could do is you could go to table, go to where x is 0, and you can see the y-intercept is at 5. So we've got a y-intercept at 5. So domain and range now. So this was a concept from grade 10. So domain, remember, is left, right, and range is for the y values. It's bottom and top. So remember with our quadratic here, so even though our screen ends, this quadratic continues to go down, and not only just down, but down and out. It's getting wider and wider and wider as it goes. So this graph has no limit on the left-hand side. It doesn't stop. It goes forever to the left. It also goes forever to the right. It goes forever and ever, ever in that direction. So when there is no number that I can plug in for the left side and the right side, we write x is real. Now, we can also see that this graph goes down forever. So this graph will not have a bottom, but it does have a top. Remember that maximum value? So the maximum value of this graph was 5.3. So the top of this graph is at 5.3. So the range is all the y's less than 5.3. Or if you look at the graph, you can clearly see that all the y coordinates on this graph are all going to be numbers less than that 5.3 forever and ever and ever. Okay, so again, the button pushing in this unit, it was a big learning curve. We did tons and tons of practice on it, but you want to make sure that you're going through that. Okay, so another way that we can interpret quadratics is understanding certain things about the points on them. So it says a quadratic has the points 3, 5 and negative 7, 5. So I always find it very helpful just to draw a quick little sketch. It doesn't have to be perfect. So I've got 3, 5 and negative 7, 5. So we don't know if this quadratic looks like this or if it looks like this. We have no idea, but it doesn't matter actually. I don't need to know that because here's the thing. These 2 points are directly across from each other. They both have a y-coordinate of 5. So what that means then is that the axis of symmetry will always lie exactly halfway between any 2 horizontal points on the graph. It doesn't matter if the points are x-intercepts, or in this case, just 2 random points that both have a y-coordinate of 5. The axis of symmetry, remember, that's the line that divides your graph in half. So the axis of symmetry has to lie somewhere in between them. So how do you find the halfway point? Well, you can either simply count it out, or if you like to just do the math, you just add up the 2 x values and then divide them by 2. So negative 7 plus 3 is negative 4 divided by 2. So the halfway point is at negative 2. Now you can check to see if you did it right. So from negative 2 to negative 7, that would be jumps of 5. And from negative 2 to 3 would also be jumps of 5. So again, it's 5 from each. So what is the axis of symmetry? It's x equals negative 2. It's halfway. So again, that's my halfway line. I don't know if my quadratic goes like this or if my quadratic goes like that. But I do know that the vertex and the axis of symmetry will be at negative 2. Okay, so we learned that there was 3 ways to write the equation of a quadratic. We have general form. It's also sometimes referred to as standard form. It kind of depends on what book you read. We have vertex form and we have factored form. So general form, so first things first, the A, B, and C, whoops, I hit the wrong thing here. The A, B, and C, those are all numbers. Notice you've got x squared and x, and again, you have to have that x squared there in order to have a quadratic. So typically whenever we have anything in general form, we just punch everything in on our calculator and we use our second calc buttons to find anything that we're looking for. Okay. For vertex form, it's called vertex form because it helps us find the vertex. So A, H, and K are going to be the numbers. So we learned some patterns. We learned that when we went plus K, the graph moved up. When we went minus K, the graph moved down. When we went x minus h, the graph moved right. When we went x plus h, the graph moved left. And then we learned that when a is a positive number, we have a smile. And when a is a negative number, we have a frown. Okay? And then lastly, factored form. Factored form again. What factored form is really good for, whoops, it's just kind of jumping around on me here. What factored form is really good for is, again, the a value. Again, if it's positive or if it's negative, tells us the same thing as it does there. But this tells us our x-intercepts. So vertex form is really good for finding just the vertex. Factored form is really good for finding the x-intercepts. And general form is just a generally good formula that we use for our graphing calculator that helps us find everything, right? Graphing calculator will find the vertex, will find the x-intercepts, the y-intercepts, everything. Now, what you do want to note is that they all have an a value. So every single one of these equations has an a value. So a, a, a. What that means then is that it's going to be the same a value in all of them. So in math, if we use the same letter, then it has to represent the same number. So if you find the a value in general form, it's going to be the same a value for vertex form and factored form. You can just copy it in. So what we're going to do here with this information is we're going to find the equation of this quadratic. So the first one we're going to do is just vertex form. So for vertex form here, here's our vertex right down here. So we always start from the origin, and we're just going to count and figure out where this is at. So 1, 2, 3, 4, 5, 6, 7. So it went 7 left. Oops. And 1, 2, 3, 4, 5, 6, 7, 8, 9 down. So let's do that first. So we'll leave out the a value for right now. I'll come back to it. So 7 left. The way we show 7 left is you go x plus 7 inside the brackets. And the way we show 9 down is you go minus 9 on the end of the bracket. Then for the a value, what we do is we go from the vertex, and you go 1 over in each direction. So you go 1 over in each direction. And then here we're going to go up 2. So because I'm going up 2, I write in positive 2. So the a value is 2 over 1. Essentially, we find the a value very similar to the way we found slope in grade 10. It's essentially just the rise over run. Now, what you can do to really help yourself out is you can check on your calculator. So if you plug this equation into y1, it should look exactly like that. And if it doesn't, you know you've put in the numbers wrong or you've put in the signs wrong, but you've made a mistake. Okay, so it says determine the equation of the quadratic function in factored form. Note a equals -3 for the equation. So it's told me, so factored form again, remember is this. By the way, you're given all the formulas. You don't have to have them memorized, you just have to know how to work them. So I'm just telling you what a is. Notice it's -3, and it's negative because we went 1 over and we went down 3. It's just the reason why I gave it to you is because it's a little bit hard to see on this picture. So these two brackets represent the x-intercepts. So I have an x-intercept at -5, and I have an x-intercept at +2. So if the x-intercept is -5, then we write x plus 5. Do you remember? We have to do the opposite. And if the x-intercept is at +2, then we write x minus 2. And that's it for factored form. Now again, you can check this on your calculator. So if you plug this into y1, you should get out exactly that picture. Okay? Okay, so now we're going to bring this all together. So I've given you one quadratic here, and we're going to find the equation of it in all 3 forms. So I'm going to blow up the page here, but just to show you kind of what I'm starting with here. So we've got factored form and vertex form. So right here I've said you can start with either of these forms, it doesn't matter. Remember, the a value is the same for all the equations. So let's start with factored form just because that was the first one that was given to me. So factored form, remember, is x-intercepts. So I've got an x-intercept at -3, 1, 2, 3, 4, 5, and an x-intercept of 5. Now for the a value, you go from the vertex. So we're going to go 1 over, and then this point here is at 9.5. So I went down 0.5. So for the factored form, a is -0.5 over 1 because I went down a half and over 1. Now, my first x-intercept was at -3, so I'm going to write x plus 3. And my other x-intercept was at 5, so I'm going to write x minus 5. And that's it. That's done. So for vertex form now, I'm just going to keep the -0.5. Okay, and I have to figure out the other part. So vertex form means we have to go from the vertex. So right here, my vertex went 1 to the right and 10 up. So 1 to the right is shown inside the bracket, and 10 up is shown on the end. So 1 to the right, we write it as x minus 1, and 10 up, we write it as plus 10. Okay, now what you can do at this point is, again, you have your calculator, so you can check. You could plug this one into y1 and this one into y2. And what will happen is that when you plug one into y1 and one into y2, not only should they sit right on top of each other, they should also look exactly like the picture I gave you. So if they don't sit on top of each other, if they don't look just like the picture I gave you, you've done something wrong. Either you've got both the factored form and vertex form wrong, or you've got one of them wrong. But you have to go through that. It's a really important step to check, because then you'll know if you're doing it right or not. Now, once you've got it to this point, we can now convert either one of these answers into general form. Now, usually the easier one to convert is the factored form. So I would always recommend you go with that one. It's just a little bit easier algebra. So I'm just going to bring it down here. I'm just going to write it out again. So it was x plus 3, x minus 5. Okay, so we're going to do some basic BEDMAS here. So in BEDMAS, the first letter you see is B, and B is brackets. So I'm just going to multiply those brackets out. So you can either go x plus 3, x minus 5, or you can do it by FOIL. So x times x, negative 5 times x, 3 times x, negative 5 times 3. Or some of you do like distribution. So you separate up the first bracket, and then you write the second bracket after it, and you multiply that through. So x times x, negative 5 times x, 3 times x, 3 times negative 5. Notice, same 4 terms. So now we've got y equals negative 0.5. I've got x squared. Now right here, I've got negative 5 plus 3x. So that's a negative 2x. And what I'm going to do is I'm going to multiply this negative 0.5 through, right? Because brackets come first, and then multiply comes second. So we've got negative 0.5x squared plus 1x plus 7.5. And what you could then do is you could plug this guy into y3, and again, what should happen? All three equations should lie right on top of each other, and they should all look identical to the one that I gave you. Okay, so knowing how to go through this process and figure out where things are lying, okay, and using your calculator to check is a super important concept in this unit. So if you need to go back and watch this example again, I suggest you do that. This is probably one of the most important things that we did in this whole course. Problem solving. Okay, so problem solving, we're going to use our calculator to do all of it. But the most important thing is window settings. Because again, the calculator can only find what it can see. Now, almost all of our graphs are going to be drawn in quadrant 1. And the reason why is because most of the time, our x-axis will be time, and time is not allowed to be negative. So if we just read the question here, it says, trap shooting is a sport in which a clay disc is launched into the air by a machine. Competitors are required to shoot the disc with a shotgun while the disc is in the air. The height, ht, so again, it's just written in function notation. This just means that the height is related to the time. So the height is related to the time. In meters, so again, we want to make sure we know our units, of one clay disc after it is launched is modeled by the function this, where t represents the time after the launch in seconds. So it says determine the maximum height of the disk and state the domain and range for this function. So what we're going to do is we're just going to plug this into y1, and we're going to use an x wherever we have a t. So I've got negative 5x squared plus 30x plus 2. So I'm just going to clear out what I've got here. So negative 5x squared plus 30x plus 2. So I'm just going to hit graph because I have no idea what this thing's going to look like, and then I'll change my window settings from there. Okay, so we can see it going up, and we can see it coming down, but we can't see the top of it. So when I go to window, okay, so I just need to go to 0 on my x because I only need to be in quadrant 1. I can see it coming down, so I don't need to change my x max. For my y min, again, I can't have a negative height, so I only want to be in quadrant 1. But I can't see the top of it right now, so I'm just going to do a random guess. I'm going to go with 50. Okay, and I'll see if that works. So it goes up, yep, and it comes down. Okay, so this is the picture that we just, all you have to do when you do these is you're just going to draw it like this. Now, make sure you put dots on the end, not arrows, because arrows would mean it could go on forever, and we know that this clay cannot go on forever. So determine the maximum height of the disc. So the maximum height is right here. So we want to know the maximum height. So this means we have to find the vertex. So a couple minutes ago, we talked about how to find the vertex. So second trace. So because the vertex is at the top, we want to use number 4 for maximum. So again, number on the left, number on the right. So I'm going to go for 1 on the left. I'll go with 7 on the right. Hit enter to get past guess. Now, I don't care about the 2.99999. All I care about is the 47 because that's my maximum height. So this is 47. So what is the maximum height? It's 47, and then don't forget, you must put your units in. So state the domain and range. Okay, so we're going to go back to our formulas. So left, right, and bottom. Oops. Bottom and top. Okay, so because again, you're not putting arrows on the end, this graph does not go on forever. So the left side of this graph is at 0. We do not know where the right side is, but in order to find the right side, we have to find what that x-intercept is, because that will give us our right. So how do we find an x-intercept? We pick number 2. That is our x-intercept. So again, we're looking for this point right here. So a number on the left, I'll pick 3. A number on the right, I'll go with 9. Hit enter to get past guess. So I get out 6.1. Or in other words, this clay hit the ground after 6.1 seconds. So it was in the air from 0 to 6.1 seconds. So for the range, the bottom of that graph is at 0. That's when it hits the ground. The top of that graph was at 47 because we already know that's the maximum. So there is our left, right, and our bottom top. Okay, 1 second. Okay, so let's continue on to another problem-solving example. Okay. So it says a ball thrown from the top of a building follows a path given by, and again, there's the question, where d is the distance on the ground in yards, and hd is the height in yards. So this one was a little different in that we don't have time. So h is the height, so that's this one right here, and it's in yards. And then d is the distance, also in yards. So what this is we want to find out how high this object gets thrown and how far this object gets thrown. So there's no time here with this one. So the questions are, does the ball ever reach a height of 60 yards? If so, at what distance? Using any method of your choice, find the maximum height of the ball. And using any method of your choice, find the distance to the nearest whole yard that the ball is thrown when it hits the ground. Okay, so let's plug this into our calculator. Okay, so just be very careful with those decimals. So negative 0.05 x squared and then we've got plus 1.25x and then 36.1875. So again, don't worry about the messiness of the numbers. Your calculator is going to deal with it. So again, I still have my window settings from the last question, so I'm just going to leave them there and just kind of see how accurate it is. So I can kind of see it slowly going up, but I sure as heck can't see it coming down. So I'm going to have to really increase my X max this time. So I'm going to make my X max go to 50, and we'll see if that works. So I can see it coming up, and I can see it coming down. Okay, so that is the picture that I'm going to draw. So again, it's just a general sketch. And again, we just put dots on the end because again, it can't have a negative height and it can't have a negative distance. So again, we only want to draw it in quadrant 1. So does the ball ever reach a height of 60 yards? So again, we want to know if it does get up to 60 yards. So what we probably want to find is the maximum height of that ball. So if we can find out if that's at least at 60 yards high, then we'll know if it reached it. So because it's at the top of our curve, again, I'm going to pick number 4 for maximum. Now remember, I went from 0 to 50 on my x-axis. So for a number on the left, I'm going to go with 5. And for a number on the right, I'll go with 20. So my peak there is between those arrows. Hit enter to get past. So I have 12.5 and 44. So this is at 12.5 and this is at 44. So does it ever reach a height of 60 yards? Nope. If so, at what distance? Well, that doesn't apply. So it says using any method of your choice. So again, we're choosing the graphing calculator. What is the maximum height of the ball? That is 44 yards. Using any method of your choice, find the distance the ball is thrown when it hits the ground. So we're looking for, so here's the ground right here. That's what we're looking for. So in other words, we need to find an x-intercept. So to find an x-intercept, we pick number 2 this time. So number on the left side, I'll go with 30. Number on the right side, so remember I went to 50, so I'll go with 48. Hit enter to get past guess. So 42.2. Oh, it says to the nearest whole yard, so that would be 42 yards. Okay, so the ball went to a height of 44 yards and a horizontal distance of 42. Okay, so that was all the stuff that we did with quadratic functions. That was our first quadratic unit. So now let's go on to our second quadratic unit. And this is where what we did is we did solving quadratic equations. So there was a couple things with terminology here. So it says the words 0, x-intercept, and root all mean the same thing. When you look at a quadratic, your eyes should always go here. So when you're asked to solve a quadratic, so if the question says solve, the answer is always the x-intercepts. It doesn't matter if the question says find the roots, find the zeros, or find the x-intercepts, or if the question just says solve and doesn't really say anything else. The understanding here is that you're looking for the x values. So just a little bit of a theory question here. So this one is written in vertex form. So we can see, because it says x plus 3 on the inside, that means it went left 3. Because it's got minus 5 on the end, it went down 5. So if I go left 3 and down, whoops, left 3, not right 3. If I go left 3 and down 5, here's where my vertex is. Now, a is greater than 0. If a is greater than 0, that means that a is positive. So remember with a, we would go 1 over, and then positive means we would go up. So I'll just go up 2. It doesn't matter how much you go up. As long as you go up, notice what we end up with is a smile graph. And it doesn't matter if you go up like that or up like this. It doesn't matter. Because how many x-intercepts do each of those quadratics have? Well, they all have 2 x-intercepts. Okay, so that's all this question asked for. It didn't ask you for the values of them. It just wanted to know how many would you end up with? Okay, so let's get into actually finding them now. So when you're asked to solve a quadratic, remember that just means you're looking for the x-intercepts. So there's 4 ways to do this. So way 1 and way 2, whoops, just jumped on me there, just give me a second. So way number 1 and way number 2 are graphing calculator. Okay, so we will go through the 2 different ways you can make your calculator find. Way number 3 was factoring, and way number 4 was quadratic formula. So these are what we refer to as our algebra methods. Now, when we do quadratic formula, again, you don't have to have the formula memorized, you just have to know what numbers go where. Okay, so let's just jump in and we're going to do 4 examples, each using the 4 ways. So this question says solve by graphing, and we're going to use y1 only. So we're just going to plug this equation into y1, and then we're going to use number 2 to find the x-intercepts. So this is exactly what we did in the quadratic functions unit. Nothing different here whatsoever. No catches, no tricks. So 3x squared minus 5x minus 4. Okay, so I'm going to go clear that out. I'm going to go 3x squared minus 5x minus 4. I'm going to go zoom 6 to return my window settings back to normal. And I get out that. So what I'm looking for are those 2 x-intercepts. So again, I just need to see that sketch on your page. You don't have to plot any points. You're just going to tell me, just going to draw that out. And now we're going to find those 2. So we're going to go second trace number 2. So a number on the left side would be like, say, -3. A number on the right, let's say, is 1. Hit enter to get past 0, and we get out -0.6. For the right side, again, second trace number 2. So this time a number on the left, I'll put it in as 1. A number on the right, I'll pick 5. Hit enter to get past guess, and I get out 2.3. Okay, so when you're asked to solve by graphing, it's just, again, using the same buttons that we were using in the other unit. No tricks. Okay, whoops. I think there was another one there on that page. Yes, I'm just going to move this guy up. And then just need to erase this. Okay, so here's another type of question. So it says solve by graphing, use y1, y2. So what this one would be is we're going to plug this side into y1, and we're going to plug this side into y2. And then instead of looking for the x-intercepts, we want to find where they intersect each other. But again, we're only going to give out the answers for x. We don't actually care about the y coordinates. So the nice thing with graphing calculator is you're just going to plug things in exactly as they appear. So we've got 3 plus x and 2 minus 5x. So 3 plus x and 2 minus 5x. And then into y2, I'm going to plug that -4. Okay, so we're just going to plug it in exactly as we see it. I'm going to go graph. I'm going to see what happens. So there's the first. And there's the second. Okay. Now again, what I'm looking for are these intersection points. So it doesn't really matter that I can't see the top. I just need to be able to find those intersection points. Whoops, let me just get rid of that. So I'm just going to bring this over here. So what I'm looking for is this point right here, just the x value, and this point right here, just the x value. Now, intersect is a super nice feature. We did use it a fair bit in this course. So it's found under the same menu, but this time you pick number 5. And all I'm going to do is I'm just going to move the cursor. I'm just going to use the arrows, and I'm just going to move it fairly close to the point I'm looking for. So right about there. So once you've got it fairly close, you now hit enter 3 times. 1, 2, 3. And again, all we care about is the x value. So it's x equals 0.6. Oops. Now, we're going to repeat the process. So second trace, pick number 5. This time I have to move, I'm going to use the other arrow, and I'm just going to move that cursor just in the vicinity, fairly close to the other line. It'll come back here in a second. There we go. Okay, so it doesn't matter where you put it, somewhere in the vicinity is fine. Hit enter 3 times. So this x is -3.2. And that's it. Those are our 2 answers. Okay, so knowing how to just use the y1 feature and finding the x-intercepts, or using the y1 and y2 together and using the number 5 feature. Okay? Okay, next method was solving by factoring. So we covered a lot of factoring in 10C. It's back again here. So most of your questions will be trinomials. So when we do trinomials, this is first, we do this one second, and we leave this one till the end. So remember, the first one goes in the middle square. The plus 12, or what we do second, goes in the bottom square. And then if I use my highlighter, if I highlight the diagonal, I write equals, and again it's negative 7x goes off to the side. Okay, so you're going to ask yourself what times what? So what times what is x squared? Well, that is x times x. And now you're going to ask yourself what times what is 12? So I'm going to go with 3 and 4, and I'm going to go all the way up and all the way over. Now I'm going to fill in the diagonal. So 4 times x is 4x, 3 times x is 3x, and if I add them, 4 plus 3 is 7, but I need negative 7. So the way I do that is to make them both negative. So now I have negative 4 plus negative 3 is negative 7. If you insert negatives, you have to bring them out. Do one final check. X times x is x squared. Negative 4 times negative 3 is still positive 12. So my factored form is x minus 4, x minus 3 equals 0. Now again, you're asked to solve. Solve means to solve for the x-intercepts. So once we have it in our factored form, remember, we just do the opposite. So x minus 4 means our x-intercept is at positive 4. X minus 3 means the x-intercept is at positive 3. And that's it. Okay, let's do one more, a little bit harder factoring this time. So it might take you a little bit longer to figure out the combination of numbers. So again, the 3x squared, we'll deal with that one first. The negative 2, we deal with that one second. And then we take our diagonal. Now, what is a handy feature, what I suggest you get in the habit of, is putting in that 1. Okay, because it will give you something to add to. Okay, so what times what is 3? Well, 1 times 3 is 3, and x times x is x squared. What times what is 2? Now what I'm going to do is I'm going to actually do it wrong, just to show you what it looks like, and then I'll go ahead and do it right. So I'm going to put the 2 here and the 1 here. So 1 times 2 is 2. That is correct. We're not going to worry about the negative till the end. So now I'm going to go 1 times 1 is 1. 3 times 2 is 6. Now I know that this is wrong because 1 plus 6 will never give me out 1. It just won't. No matter what I do, it will not work. So what I have to do is I have to go and say, okay, well, putting the 1 here and the 2 there didn't work. So I'm just going to switch it around. I'm going to try putting the 2 here and the 1 there. So 2 times 1 is 2. 1 times 3 is 3. Now 2 plus 3 is 5. But if we put in some negative, then it will work. So if you want to do on your calculator, your choices are negative 2 plus 3, 2 plus negative 3, negative 2 plus negative 3. Which one gives you out the positive 1? Well, it's this one. So I'm going to make the 2 negative. So I'm going to bring it out. So my brackets are x plus 1 and 3x minus 2. Now also notice when you do a check, 3 times 1 is 3. Negative 2 times positive 1. Sure enough, that gives you that negative 2. So the negative took care of itself. So again, that's the factor. Now we have to go and do the solve. So remember, we do the opposite. So if it's x plus 1, the x-intercept is negative 1. Now for this bracket, just do one little thing. You just have to do one little extra step. Hide the 3. So if the bracket was x minus 2, the answer would be positive 2. Okay, but there's a change here. X is being timesed by 3. So what's the opposite of timesing by 3? Dividing by 3. So my x-intercepts are at negative 1 and positive 2/3. Okay, so that is solving by factoring. Now, of all the algebra that we do in this course, probably solving by factoring is probably the biggest carryover skill that you need for 30-2. The last carryover skill for algebra is solving by quadratic formula. So when we're looking at our equation, the a is the number in front of the x squared, the b is the number in front of the x, and the c is the number by itself. Now, you'll notice in the formula that it starts off with negative b. All that means is you're just going to put in the opposite to whatever's in the equation. Okay? So A, B, C. So I always get in the habit of writing A, B, C underneath each of my numbers. So that way it reminds me which numbers go where in the formula. So right now B is positive 4. So the first thing I'm going to write, the opposite of positive 4, is negative 4. Now, next thing I have is B squared. So positive 4 times positive 4 is positive 16 minus 4 times A times C. Now remember, C here is negative 5, so don't forget that negative sign. And that is all divided by 2 times A, and A is 4. So now what we're going to do is we're just going to use our calculator to help us simplify. So we're just going to take our calculator and we're going to plug that part in. Don't hit the square root sign, just plug in that number. So we've got 16 minus 4 times negative 5. So 16 minus 4 times negative 5. And I get out 96. Okay, so there's two ways you can be asked to have the answer. You can ask for it as an exact radical or as an approximate. So as an exact radical, what you would do at this point is go back to the radicals unit, the one that we just reviewed, and we're going to take down that 96. Okay, now because it's even, I know it's divisible by 2. And because it's even, I'm just going to keep dividing it by 2. So I've got my groups of 2. So I've got 2 squared, another 2 squared, and then the 2 and the 3. So both of those get to come out. So I've got 2 times 2 on the outside and 2 times 3 on the inside. So I've got 4 and then 6. And then one more step. What you have to do is you have to look at just the coefficients. So 4, 4, and 8 can all be divided by 4. So my exact x-intercepts are negative 1 plus minus 1 root 6 all over 2. Okay? For the approximate, all we're going to do is we're going to plug these in on our calculator. So you're going to go, so the first one you're going to go negative 4 plus root 96, put it in brackets, and then go divide by 8. And then for the other one, you're going to go negative 4 minus root 96, and then divide it by 8. So again, use your brackets. So we've got negative 4 plus root 96, whoops, root 96, and then divided by 8. And then you've got negative 4 minus root 96 divided by 8. So my two x-intercepts are, whoops, I punched something in wrong here. Oh, I forgot my first bracket here. Let me just go back and put that in. Okay, so we've got so the first one was 0.7 and the other one was negative 1.7. So 0.7 and negative 1.7. So I know it seems weird to show x-intercepts in this exact form, but sometimes in some contexts, we actually do need that very much of that exact answer. Having the decimal just doesn't always cut it for us. Okay, so I know it seems weird to show a number in this weird fraction square root way, but it actually is a useful way for us. Okay, so let's do one more together, make sure we're clear on this. So again, this is my A, this is my B, this is my C. So I've got x equals, so I'm going to start off with negative b. So again, it's the opposite of whatever's happening here. So it's going to be positive 13 plus minus. And then on your calculator, negative 13 times negative 13 is positive 169 minus 4 times a. And then again, c here is negative 7 all over 2 times a. So now we're just going to use our calculator. So 169 minus 4 times 2 times negative 7, and I get out 225 over 4. Okay, so for the radical now, so I'm just going to simplify this down. Now, in this case, it's a perfect square. I know that if I were to go through and do the division, so if I were to start off by dividing that by 5, I get out 45, divide it by 5 again, and then divide it by 3. Notice I have only groups of 3s and 5s. I don't have anything left over. So again, what happens there is I'm just left with 5 times 3, so I'm just left with 15. The square root goes away. So when I'm looking for my 2x-intercepts, I would go 13 plus 15 divided by 4 and 13 minus 15 divided by 4. Again, brackets. So I get out 7 and negative 0.5. So sometimes when it asks for the exact answer or the radical answer, sometimes the radical does go away. Okay, it doesn't happen very often, but it can happen. Now, if you're doing the approximate answer, again, at this stage, you would just go ahead and plug this in on your calculator. But again, make sure you put that into the brackets. And then you're going to get out that answer. And then when you plug this one in on your calculator, you get out that answer. So again, they do match. Okay? So don't freak out if the square root ends up going away. It just means that you had a perfect square as part of it. Okay, one more question that we did in this course, in this unit, was maximums and minimums. Okay, so there was a very set way that we did these questions. We called them tipping point questions. Like at what point, how much can you charge before you start charging too much and you end up losing money on your deal? So it says a hockey team knows you can sell 150 season tickets today at a price of $120 per package. For every $20 increase in price, they will sell 12 fewer packages. So when we create our equation, the questions always look the same. We will always have one bracket dealing with number and the other bracket dealing with cost. And if you take the number times by the cost, you'll always get out your profit. So each bracket starts with the base number and the base dollar. So the base number of tickets was 150 and the base price was $120. Now the next part says $20 increase. So into the dollars bracket, we're going to show plus 20. And then it says sells 12 fewer packages. So that will be minus 12. Now the most important part is that at the end of each bracket, you must put the x. And the reason for that is, remember, we're dealing with quadratics. When brackets touch, that means times. So I'm going to have x times x. That's where that x squared comes in. And you have to have that x squared there, otherwise you're not going to get out that U-shaped graph. Now, every one of these questions will look like this. So you do a dot, you go up, and you come down. The hardest part of this is your window settings. So let's go and plug this in on our calculator. Now they're all set up the same way. It goes base, base, and then one's going to be plus, one's going to be minus, and you just put that rate in there. Okay, so 150 minus 12x, 120 plus 20x. Okay, so 150 minus 12x, 120 plus 20x. Okay, so when I go graph, I'm not expecting actually, so I've got like a straight line going up, but that's it. So I'm gonna have to just start from scratch here. So I know I only want quadrant 1, so I'm gonna go 0. I need to increase my x max. Let's go with 30. For my y min, again, I want to be in quadrant 1, so I don't need anything negative. So I couldn't even see the top of that quadratic. It just looked like a straight line going up. So I'm going to go with 5,000 because I'm going to have to go fairways. So let's see what that does for me. Oh, so now I can see it coming down, but I still can't see the top. So let's go with 20,000. Oh, I can almost see the top. Oh, so close. So let's go with 30,000. Okay. Now, the point that we're looking for will always be the vertex. So I am looking for this point every single time. I want to know that, and I want to know that. So it's at the top of the curve. So it's going to be number 4 for maximum. So left bound, I'll just go with 2. And, ooh, I was just barely to the left there. And right, I'll go with 6. Okay, hit enter to get past guess. So I get out 3.25 and 20,535. So 3.25 and 20,535. Okay, so determine the maximum amount of money the team can make. So the maximum amount of money will always be this number right here. So that's the maximum amount of money that this team is going to make. Now, how much will they sell the packages for? And how many packages will they sell? Okay, so how much? So this is the dollars. And how many? This is the number. So what you do now is you rewrite out your bracket. So my dollars bracket was 120 plus 20x. And my number bracket was 150 minus 12x. Now, from right here, I know what x is. X is 3.25. So on my calculator, I'm just going to go 120 plus 2 times 3.25. And here, I'm going to go 150 minus 12 times 3.25. And that will give me out my answer. So 120 plus 2 times 3.25. So I get out $126.50. And that's per package. So that's what I should be selling the packages for. So I shouldn't be selling for 120 bucks. I should be selling for $126.50. Okay? And how many packages can I sell? Well, 150 minus 12 times 3.25. And that is 111 packages. So even though I'm going to be selling less packages than the original 150, it doesn't matter. I'm going to be making more money. I'm going to be making that maximum amount of 20,535. Okay, so with these maximization questions, you have to know how to set up these formulas. They're always set up the same way. Okay, they're base plus or minus rate. One of them will always be number. One of them will always be dollar. Okay, so I know that that was a big review. Okay, but quadratics is probably the biggest and most important unit we do in this course. Make sure that you do the practice questions, and we will see you in the next one.